Okay, now I'm going to start talking about the constant percentage change. Now I'm going to arrange this in two parts. So this is going to be the first part, and then I'm going to put a video on here after this with the second part. So this is a typical formula. This N of t equals C, and then in parentheses 1 plus R of t. Now, this is a typical problem you could see with interest, and if you take any kind of like business and finance economics class. So the N of t is going to be the new value. C is the old value, or in other words, it's what we start with. It's our initial value. R is a rate. So rate, think of percentage. Like think if you go to a bank and get like 5%, 6%, with a car, you may get like a 2.9%. We're thinking about percent. And then our exponent is t. This is time. Now time can be over years. It can be even a monthly, over several months. Now, growth factor. Previously, we were talking about growth factors. Now, anything with a growth means that it's above 1. In this case, 4.7 is above 1. So what I want to ask you is to find out when the growth factor is 4.71, what is the growth rate percentage, or what is the percentage of growth rate? So if you look up on the rate in parentheses in our N of t equals C, and then in parentheses 1 plus R to the t power, the growth factor will always be that 1 plus R. Now, we already know what the growth factor was. It's the 4.71, and we just set this up equals to 1 plus R and solve for R. So to solve for R, all we have to do is subtract 1 on both sides. And you get 3.71 equals R. Okay, now the key to this problem is it's wanting to know what the percentage is. So anytime you're asked for percentage, you need to take your answer and multiply it by 100%. So in this case, R comes out to be 371%. Just a similar example. Growth factor 6.49. And what is the percentage of growth rate? So if you want to pause and give yourself a couple minutes to work on this, and then unpause it to see if you actually got this correctly. So remember, on this one, you still need to find what the percentage growth rate is. So we do know that our growth factor is 6.49. We set it equal to that 1 plus R. Subtract 1. You get 5.49 equals R. Multiply this by 100%. And you should get 549%. Now, my last one, and then I'm going to start part 2, is, let me scroll back up here real quick. Okay, we're going to say Bill has a credit card balance of $850, and he has this monthly interest rate of 1.5%. So even though 1.5% looks really good, the key to this is a monthly rate. So but the problem is a monthly rate. It's not a yearly rate. So what I want you to do with anything, if I give you a percentage, instead of multiply by 100%, you take 1.5, divide it by 100, and you get 0.015. Now, this is the rate. If you could remember from our problem or our equation, the n of t equals c and then parentheses 1 plus r. This is the r, this is the rate, so you have to add 1 to it. And now what our equation will look like, because now we've got what's in that parentheses, now we can say our exponential equation is n of t equals, okay, we start off with 850. Now in parentheses will be 1.015 raised to the t power. Now remember this right here, I'm just adding 1, that's where I got the 1.015. So the next question is, what happens when what's the balance if it's not 9 months? That means if we don't pay anything on the credit card. So that t now is 9. And what we do is we put 850, 1.015 raised to the 9th power. Now make sure that when we're using our graphing calculators, that you put it in just like how I have it written. I want you to put it in 850 and then in parentheses 1.015 raised to the 9th power. And you should get something like this. 971.86. Now the last one, this is something that I'm going to show you how to do this on the calculator. So on your graphing calculator, it means what happens when it reaches $1,000. That means if we don't pay anything, any kind of minimum, how long will it take you to get up to $1,000? Well, on our calculator, we have that y equal at the top left part of your calculator. So if you push that, my y, you get y1, y2, and a bunch of them. We're only going to do y1 and y2. Now y1 is our original equation. It's 850, and then in parentheses 1.015 raised to, we can't use t on our calculator, so we're going to use x. Now the y2 I want you to put in, we're trying to figure out what happens when it's 1,000. Now this is going to be a two-step process of finding this. So you need to, the first step to this is to locate your second button. Then at the very top there's a trace. So you hit second and trace, and gives you the calculate. Once you hit the calculate option, you need to look at number 5, which is intersect. So this should look pretty familiar to what we've done before. Now, once you continue to hit first curve, second curve, and guess, and then it will give you an intersection, we're looking at what x will be. So in this case, I come out to be x equals, we should get something like 10.92. So anytime this is just like what we did in the linear functions or linear equations. You got your y1 and y2, put your equation in one of them, whatever we're trying to figure out in the second one, because if you're trying to figure out what the time is, we're trying to figure out what that exponent is. So if you put second trace, that gives you the calculate, option number 5 intersect, this is what you can come up with your exponent. Now later down the road, I am going to show you how to do this by hand, but right now I'm just showing you how to do this by a calculator. So this concludes this portion. I'm getting ready to work on the second portion of this. And you will hear from me here in a few minutes.